This is practice 1. In here we're going to explore how to use a cluster in the LabVIEW. And in this example, in one cluster include many different data formats such as bulletin, data format, and numeric, and knob, and string. And after you include everything in one cluster, in order to access each different format of data sets, you have to unbundle them, as you see in this example. So let's make this simple VI where we use the cluster. First, we have to create the cluster container. So this is data container and cluster. So you can just select the cluster. Because we want to add many different data type inside cluster, let's make this one is a little bit bigger. Then let's just add anything else. So we want to add the numeric control. We want to add like a button here. Okay, so this is a button. And then we can add the string. For example, this is string constant, string control. I want to add string control, and then we also add the knob. So in here the knob is from numeric, and this is knob. Okay, so now I just add everything. Then you can control each different thing here. So I can type any number here, and you can turn on, turn off this boolean like a button. Okay. Now, however, if you want to access each the variable, you have to unbundle this cluster. So go to the function palette, okay, and then there's a cluster folder here. So if you go to the cluster, there's a unbundle by name, unbundle. So let's try to click unbundle by name. So you connect this one to there, then automatically if you see that if you just extend this one, you can see that all different format of data we already created inside a cluster. So automatically the cluster recognized all different control inside the cluster. So from now on we can easily take any variable out. So for example, I want to connect this one to indicator. So this is numeric indicator. And then this is a string indicator. This is a string indicator. And this is a boolean indicator. Like that. So after that, if you run, then you can get the extract the information from the cluster. So now your numeric control is 56, so that's why you see that 56 and hello, and this is on. And then speaking of the unbundle, you can also use this unbundle without the name. So for example, if you just click this one, you can connect this one. Then now instead of the name, this one actually shows that data format. So double precisions and boolean and string. So you have to understand which one is which one. So that's why by name is more clear which one you want to really access inside of the cluster to extract the information. This is practice 2. In practice 2, we are going to make a VI that display any random number generated every specific milliseconds on the charts. So as you see that we have a stop button, so you kind of understand this chart functions is inside of a while loop. And then we want to generate any number so that the generate number will be displayed on this chart as a function of time. Okay, so right now on the chart is like displaying your plot. So click on the right button and there's a graph, and there is a waveform chart, waveform graph. So let's work with a waveform chart first. So this is a waveform chart, and after that, as you just connect any a number to this waveform chart, the waveform charts display that number as a line here. Right now, let's just create the random generator. So I search random generator. So the random generator between 0 and 1 is under number. So I just pull this one to block diagram and connect this one to there. But if you just run, this is just one time run, so maybe this one just display only 1 points. So in order to just keep generating the number, I want to make while loop. So go to the structure, and there's a while loop. So I just click and then while loop, and then I need to create the control button. So this is my control button to stop the while loop. And then if you just run, I think this is too fast because the while loop executing this random generator as fast as this computer can. So I think this is too fast. So let's try to control the time interval between generated variable by inserting time wait. Okay. So in the program, and then there's a timing folder, and then in here we have a wait time. So let's try put this wait time, and then we can try to connect the control. So I want to control the time interval by clicking this number. So at this time, let's say 100 milliseconds. So which means at every 100 milliseconds, the random generator generates the number, and that number will be displayed on waveform chart. So let's run. So that's why you see those kind of, this is pretty slowly moving on, because every 100 milliseconds, the new value will be generated and displayed on this screen. Then in the plot, there's different options here. So you can change the color. I want to change this line as a yellow. And then you can change the line style. So if you want to change the line style to dotted line, you can change that. And then you can change the line width. And then you can even change the plot type. So this is kind of this is just a line, and this is like a bar graph. So just make a vertical line. And then what else? Right now you can add the points. So let's say, so you can each random generated value marked is displayed on the mark because you added that. So there's many different options here. Okay. And then also you can change the Y scale. So right now by default this is 0 and 1. So if you want to make this one is a little bit wider, you can just type 2. But right now this is forced back to the 0 and 1 because if on the right click here, there's auto scale X, Y. So uncheck the auto scale Y, then if you change this one to 2, then you can change your Y scale range. So let's say -2. So you can change the X scale. And then so this is a clear chart. So I think this is pretty much it for practice 2. And this one, let's make this one a little bit thicker. And this one also thicker. This is practice 3. Practice 3 is similar to the previous practice, but in here we create the VI that display multiple line on the waveform chart. Before we just display only one line, but sometimes you have multiple generated signals, then you may want to plot multiple lines on the waveform chart. Then I'm going to use our previous build's VI. Instead of one random generator, I just created 3 random generator. Then I have to actually bundle this one to show the multiple line. So if you go to the programming and cluster, there's a bundle icon here. So click the bundle icon and then expand this one to 3 so that you can add click and connect all the generated random variable into this bundle icon, and the output cluster goes to your waveform chart. Then since we added the 3 plot, you can expand this one to 1, 2, 3. So you can change the different color if you want. So you can change this color as blue, and this is kind of green. So you can change line width is a little bit thinner. After you just adjust different line type, line scale, line types, line thickness, and so on. Then if you run, now you see that we have multiple lines going on. This is practice 4, and practice 4, unlikely the previous practices, we want to create the scatter plot. So in the previously, when we used the waveform charts, the x-axis is the timestamp. So we don't care about what x value should be. However, in this one, we have multivariate signals x, y. So we want to make a scatter plot. X is not time, x is a certain variable x. Right now, your x is any value between 0 and 10, y is any value between 0 and 10. So we are still using the random generator, but we scale up our random generator up to 10. And we don't need, we use the express xy or xy graph. So let's go back to our LabVIEW. So I'm going to use our pre-built the VI. It still has the same while loop, and I created 2 random variable. And in order to scale up the random variable range, I just multiply 10 to the random variable. Okay, so these are my x, this is my y value. Then in order to make this one as a xy scatter plot, click on the right button on the front panel and go to graph, and there's a 2xy graph, but let's just select xy graph. Okay. And right now, after that, you have to bundle these 2. Okay, you have to bundle these 2. So go to the bundle. So bundle icon can be found in under cluster. So this is bundle. So you have to connect the bundle here, and then x to this one and x, y to this one. However, we still have some error here. So right now, the xy graph actually expects your variable out, this variable, to be array, not single scalar value. So that's why before you make a bundle, you have to convert your single data value to the array form, to the array. So in order to do that, let's go to the array, and there's a build array. So click the build array. So you want to change the single area scalar value to the array. Okay. So actually this is array with only single elements, but we just changed the format. And this one too, so the second one too, so single scalar value, but we just convert to the array format and bundle them and then connect to XY graph. Then this one, this is a while loop, so at every 100 millisecond XY value will be generated, and then just make some plot on here. Right now, let's try to just change this one as like a dot plot. So I want to make this as common plot as a dot, and this is a dot plot. And then I don't want to make auto scale, so I just uncheck auto scale X. I just uncheck the auto scale Y. So the 0-10 is kind of pretty fixed on here. And then let's run. So now you can see those kind of dot is kind of moving around. So whenever random variable generate the value, this one just to display what is XY value of two variables, but it doesn't actually stack on it. So XY graph actually just to display the array data sets, but it doesn't keep the previous data points on the plot. It just whenever it just displays something, it just clear the plot and then just regenerate the plot on top of the graph. That's why we see only the single data set here. So how we can show a collections of data, collections of XY scatter plot here. So in this one, we have to do a little bit change our format. So for example, instead of using the while loop, and if you use the for loop, for example, so let me try to change our data sets a little bit, our data structure a little bit here. So let me just get rid of the while loop first. So I click the while loop, and then in here, remove the while loop here. I just remove the while loop, and then I just remove the stop button as well. And then in that case, I don't need this time wait as well. So in here, let's just place this random generator into the for loop. Okay, so for example, this is programming and structure and the for loop. So let's say we create 100 data points. So I want to put the 100 data points. So this random generator just create 100 data points, and then I want to connect this one to the exiting edge. So this is auto enabled. So after this for loop ends, the 100 data points come out from here. So that's the array. So I just connect this one to here. I just connect to this one to here. So this one actually has a X100 array, Y100 arrays, and then we bundle them and just display XY plot. So let's run. So in that case, we can see the 100 data points because we created 100 data points before we assign them to the XY graphs. In practice 5, we apply the concepts of using XY graph onto here. So in this one, this is XY graph, but instead of displaying the random points, I want to create like a circle dots. The logic is this one. So for example, in order to display each kind of dot points under circle, let's say we want to create XY values. but xy value just came from cosine and sine function. So let's say your angle, the horizontal angle is, let's say, 0 angle. So when, as a function of angle change from 0 to 360 degrees, which is one full round, then if you compute xy data points on it, so that this line is actually comprised by the collections of xy data points, which is cosine theta and sine theta. So if you compute the xy using cosine sine theta, and theta is just changing from 0 to 360 degree, after that, after we collect xy data points, if you plot xy on xy graphs, then you can see this kind of circle. Okay? So let's try to do that here. So let me just scroll down. In here, we want to use the for loop. We want to create 360 data points depending on each angle, 1 degrees angle. So I want to create 360 data points of xy. Then when for loop iterates, this I will change from 0 to whatever the number. So I consider this is like degrees, okay? 0 degree, 1 degree, 2 degree, 30 degrees, and so on. But before I use cosine sine function, I need to change this one to radian, because our cosine sine functions expect the value as a radian, okay? So is there any functions to change degrees to radian? So let me try to type degree. So there's a function degrees to radian function. So let's just plug this one here. So I just connect this one to degrees to radian function. So the axis is a radian. After that, I want to pull out cosine and sine functions. This is under trigonometric function. This is cosine, and then this is sine, and then I just connect this one here and here, and then this will be my xy data points. Then I want to just connect this one to for loop here, loop. And then let's create the graph xy plot here, okay? And then we have to bundle these two xy value, right? So let's go to the programming as cluster, and this is bundle, and just connect this one, and then let's make the line width a little bit thicker, and then make color as kind of green. Let's run. So now very interestingly, it doesn't show very clear like a big circle, okay? I think this is because right now if you look at this one, do you see that this kind of blue line? So this blue line represents this is integer. So when you change the degrees to the radians, this input x is an integer number. So when you compute that number, you have a lot of rounding, the rounding errors, because your output is kind of integer. It's not the like a double precision number. So we have to make a modification. So you have to convert integer to the double precision number. So let me just disconnect this one, and then let's try to convert integer to double precision number, okay? So if you go to the programming and the numeric, and there's a conversion here. So this is 2 double precision float. So click this one to there. So I just connect in integer here, and then I just connect this one, the double precision float. Then I know that this or line becomes orange color, so the data type is double precision float number. Okay. Then let's run one more time. Now this is circle. Then right now this radius is 1 because we didn't count the size of the circle. So this is just cosine xy is when you just compute cosine x, cosine sine x, the default is radius is 1. So if you make a little bit bigger size, you have to multiply some number to the output from x and cosine and sine. So for example, I want to multiply numbers. So let's just put this one, and then I connect the output from the multiplications, and then this is cosine, sine. Then let's create here radius here. This is radius. So let's say I want to put the radius 5, and this radius should be multiplied with 2, that cosine and cosine. Then you can make this as a bigger, because right now this is 5, right? This is 5. So radius becomes a 5. This is an assignment. This assignment, don't worry about understanding detail about these assignments, but I just provided 2 array here, and then if I quickly explain what this one is for about, and this is like empty can, and somebody just fill the water into this empty can. As you fill more water, this because of weight, this is a rubber band, so rubber band will be strengthened. So they measure the length depending on how much water they fill into this soda can. That's what this one shows. So this first column shows how much the rubber band is expanded depending on how much volume of water they put into this soda can. That's what this one shows. And our A is using the LabVIEW, enter the length of value as one array and corresponding weight value another array. Then plot applied force on the y-axis versus length of x on x-axis. So this one asks you make the xy plot. Okay? But I want to make a force plot on y and length on the x-axis. So how can you apply determine the force? So this is just the volume of the water, but right now the force due to the weight of the water can be determined by this equation. So your force is equal to the water density times the volume and times the acceleration, gravitational acceleration of gravity. Okay. Right now, however, when you compute this volume, the volume must be given as meter cubic, but in here the volume is a milliliter. So we have to convert the milliliter to meter cubic, and we just multiply all these values so that we can compute the force. Okay. So let's try to convert our volume to the force first. So in this VI, I already created 2 given array. So this is length and this is volume. I just create a two array and the type manually. Okay. And then using your volume, we have to just convert to the force. Okay. So first, let's put the water density. So water density. So your water density is 1000, and then put the acceleration, gravitational acceleration. This is 9.81, and then we have to change the milliliter to meter cubic. So probably we need a conversion factor, but let's do the conversion factor using constant value. Here, the 1 milliliter is equal to 10 to the minus 6 power cubic meter. Okay, that's the conversion factor. So we are going to use this one. So in order to compute the force, we just multiply everything. So I want to multiply everything here. So multiplications, numeric, and compound arithmetic here. So we have to multiply this milliliter, okay, and then we have to multiply density, and we have to multiply the acceleration, then we have to multiply the conversion factor. 1 milliliter is equal to 10 to the negative 6 cubic. So in this one we just create constant. So 1, 2, 3, 4, 5, 6. So I put the point 0.00001 here, and then this becomes the force, right? So let's just create indicator. So I put this one is force. Okay. I think this is a Newton. Okay. Let me just put the units. So this becomes our force. If you run, this becomes. My another mistake is that the density is 1000, not 10,000, right? I'm sorry for my mistake. And let's see. I found my another mistake. I'm sorry about this one, because right now when we compute the force, actually length has nothing to do with it. So I don't need to multiply this conversion factor to change the length millimeter to the meter. So we don't need to do that. Okay. So when I run it, so this is more proper, like a range of the force. So density, acceleration, and just conversion factor. Okay. After that, we have to make a plot. Okay. Y is force and x is just length. Okay. So now let's create XY graphs. This should be a scatter plot. Okay. And then we have to bundle y and x value. So this is bundle. So this force should be my y value. So this is y. And then the length should be x value, right? This is x value. And then just make a xy plot. So let's run. Now you see that this is XY plot. So if you want to change the label, this is force, and X is length as a millimeter, okay, and force is as a Newton. this is A, and B. Then convert the data to two new array, one representing stress and the other representing strain. So the stress is a force divided by the initial cross-sectional area. So this rubber band has cross-sectional area which is 5 times 0.5. This is area of the rubber band. So if you divide the force by this area, then it becomes the stress. And strain is change in the length divided by the initial length. So instead of we use our length as it is, we try to divide this length, each change of the length, by each initial length to get the strain. So we just convert data to the new array, and then we just make another plot. So in here we have to convert the force to the stress and length to the strain. Okay. So in order to do that, we have to compute the area. So area is 5 millimeter times 0.5 millimeter. That's the area. So let me just create numeric control that area, and this is a millimeter cubic. So 0.5 times 0.5 is 2.5 millimeter cubic. Okay, but we have to change the area to the meter, not the cubic, millimeter square, and we have to change this area to the meter square as well. So right now I want to change 1 millimeter square is equal to e to the negative 6 meter cubic. Okay. So first I just change, multiply this area with that conversion factor. So this is 0.000001, and then now it becomes meter square. Okay, this is meter square. So in order to get the stress, you have to divide the force by this meter square. So let's go to the numeric and divide. I want to divide this force by this area. Okay, so this becomes your stress. Okay. So let's make this one is more compact so we can see all the array together. So check the stress first. These are kind of stress. And then how about the strain? The strain refers to change in length divided by initial length. Okay. So the strain is we compute from here. So our initial length is 75. It's 75. So what we want to do is that because we just try to find the changes of the strengthening length, so I want to subtract everything. I want to subtract 75 from every element. So let's create the numeric constant value. So this is 75. So I subtract the 75 from all elements. So this is only the changes. Okay. After that, we have to divide by the initial length. So this is a divide by our initial length. This becomes your strain. Okay, so this is strain. So this is our strain. So let me just move here. So this becomes your strain. Then if you want to make another plot between stress and strain, then you can just copy paste this portion here. I just copy paste here, and then your stress goes to y-axis and your strain goes to the x-axis. Then this is second plot here. So if you run it now, we have the exactly same pattern, but because we just convert the xy, so this is becomes strain and this becomes stress. So I think this is it for assignments.